Escalation of Privileges, or I've got the power. So as we've worked our way through, we've now performed our reconnaissance, we've scanned and enumerated, we've gained our access, and now we're trying to escalate our privileges. We want to go from being a normal user to a system level user and then eventually to a domain admin. So this is our fourth step of the hacking process. It's our escalation of privileges. We're going to gain administrative, system, or root access by escalating our account privileges. After we've escalated our privileges, the next thing we're going to do is we're going to have full control over the network or system, and we can gain administrative access over the workstation and then expand out to the domain if possible. This is going to give us complete control of the network where we can do whatever we want. So what are some methods of escalation? Well, we can exploit an administrator or a system to begin with. We can steal passwords with keyloggers, or we can crack the password itself. And we can do that through the SAM database in Windows, or we can use the shadow database inside Linux. So in Windows, the passwords that you have are stored as a binary encrypted hash. So when I go to log into Windows, it actually hashes my password, and then it compares it to the hash that it has stored. If those two match, it then lets me into the system. Now, because it has this database, this SAM database, if we can steal that database, we can take it offline and we could try attacking it and cracking it. Why would we want to do that offline instead of just trying to fat finger and try to brute force our way into the system? Well, most people have set up their systems now so that you can only attempt the password 3 times and then it will lock you out for a certain amount of time. So for example, let's say that I'm trying to guess the password for my user account. And I go in there and I type in 1, and then I type in 2, and then I type in 3. And now I gotta wait 15 minutes and then I can try it again. That can take me forever if I was trying to guess the password. So instead what we do is we try to steal the database itself. We could take it offline and then we can attack it millions of times a second with a fast computer and not have to worry about being locked out because the system isn't being tested, just the password to see if I've matched the encryption. So how do we steal that SAM database? Well, one of the ways you can do it is physical access. And physical access means I actually I'm able to touch the machine I'm trying to attack. So if I get into the office and I can copy the SAM using the NT emergency repair disk, or I reset the user password using NTFS-DOS or Linen, then I can take that and just take that password from the physical access. Now, if we're hacking remotely, that's not going to be an option for us. So in that case, we need logical access, using something like Meterpreter where we can do a hash dump. Now, once we have that hash dump, we can then use that hash dump to try to crack those passwords and do something like pwdump, LCP, orfcrack, or John the Ripper. Lots of different password cracking tools out there once we have this database that we can then compare to. Now, there's many different authentication types used in Windows. There's LANman authentication, there's NT LANman authentication, NT LANman version 2 authentication, and Kerberos. So we're going to talk about LM authentication. So LM authentication is LANman authentication. It was used by Windows 95, 98, and ME. And it's based on DES, which is the Data Encryption Standard, making it very easy to crack. DES is only 56 bits long, therefore most modern computers can crack it fairly easy. Now, the reason why this is important is it's still used for backwards compatibility in some systems. So you may be able to find some LANman passwords. If you do, they're easy to crack, go and use those. Because LANman had gotten kind of outdated because of the sophistication of computers, they upgraded it and it became NT LANman. And NT LANman was used in the Windows NT systems, anything less than Service Pack 3. Again, very old systems, but it is still used some places for backwards compatibility. This was based on DES again, so 56-bit keys, as well as using a hash of MD4, which again is very antiquated these days. So NTLM version 2 is NT LANman version 2. It was used in Windows NT, Service Pack 3 and beyond. It was a replacement for the NT LANman that again had become old and antiquated. The newer version is Kerberos, and Kerberos was actually started in Windows 2000 and is still in use today. It was used in Windows 8 and Windows 2012. Now, Windows 10 has moved on to a different system, but up through Windows 8 and Windows 2012, Kerberos was still what is being used, so it's one of the more modern authentication methods. So let's talk about how LANman hashes work. Well, essentially you have a password, and it's converted to all uppercases. So let's use the code of let me in. So the password is then padded with null or blanks to make it 14 characters long. So we have let me in 1 and then blank. So we have that string, it's broken up into 2 sets of 7. So we have let me in and 1 blank, 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 blank. And each of those parts is then encrypted separately. We then push those back together with a truncation, and that gives us what our LM hash is going to be. So what is that going to look like in the real world? Well, here's a hash dump of a system. Inside Meterpreter, we use the command hash dump. It's part of the Metasploit framework and allows us to collect the remote hashes off that remote system using an interactive shell. Notice here we'll just run the hash dump and we'll be able to get the system key back. So here's what a hash dump looks like. Notice we have the administrator, he's a user 500 account, and then we have his LM hash. We have the guest, he's a 501 account, and his LM hashes. Help assistant, support, Bazinga, track, troll, all those user accounts, all of those admin accounts, and you'll see those accounts there with their LM hashes. We can then take that information offline and use something like Orfcrack or John the Ripper to then get the actual password from it. Another way to collect the hashes is using a program called Loafcrack. And Loafcrack is going to be able to extract the hashes from local or remote machines. It also can sniff passwords as they're going across the network. So if I am locally on that network, I can launch Loafcrack and I can start copying those hashes as they're going across the network and then crack them using Loafcrack. Again, this is good if you're in the local network, but if you're doing a remote exploitation, something like hash dump with Metasploit is going to be more effective for you. Another way of doing this is using a program like pwdump. And pwdump is a command line tool that can bypass the syskey encryption of the SAM if you have the admin rights already, and it can collect the hashes and store them as a text file. Once you have them as a text file, that hash dump, you can again go through and crack those passwords. So what are some methods of actually cracking a password? Well, one of the ways is dictionary, another way is brute force, and another is hybrid. So what is a dictionary attack? Well, a dictionary attack uses a dictionary or word list to crack a password. And so this is going to be the quickest method of doing it, but it's only as good as the dictionary I have. So let's talk about this. So let's say I have 1,000 words in my dictionary, and I'm trying to crack a password. Well, what ends up happening is I take the first word in the dictionary, I encrypt it, I compare that encrypted hash to the landman hash I had stolen. If they match, I know my password. If not, I move on to the next one and I keep doing it. This can take some actual time. So if I want to do millions and millions of passwords, this will take a long time. So one of the ways we speed that up is we use what's called a rainbow table. And what a rainbow table does is it's actually a dictionary, but it's already pre-hashed. So now I can just compare hash to hash instead of having to create the hash and compare the hash. So that's one way to speed up a dictionary attack as well. Another way to do this is what's called a brute force attack. Now, a brute force attack will find the password every single time without fail. The only problem is this can take forever. So what ends up happening is it actually uses random numbers and letters, and it will actually start guessing passwords. So if I say I want to check every password up to 8 characters, it's going to start with A, and then it's going to go AA, and then it's going to go AB, AC, AD, and keep going until it gets out to AAA, AAAB, AAC, and it will keep going until it finds it. This can take hours, years, or decades depending on how long and how complex the password is. But it is 100% successful. Now, when I say a long time, there are some times that a brute force attack can take you a billion years. For instance, if you have a 16-character password that's uppercase and lowercase, has special characters and numbers, that is going to take millions of years to crack with a standard computer. So a brute force attack is good if you can kind of give it some parameters. So if I can say, hey, I know the password is going to be between 14 and 16 characters, that can help because I can eliminate having to do all the work up to 14 characters, but again, it's still going to take a long time. Now, one of the ways I can do this better is I can do what's called a hybrid attack. And this is where I take a dictionary list and I can add some things to the beginning or the end of it or even in between it to work it a little bit better. And so this takes more time than a dictionary attack, but less time than a brute force attack. So for example, if I thought the password had something to do with password, then I can use things like 1Password or password123 or password where I replace the A's for ats and the S's for dollar signs. Those type of things are using a hybrid attack. Where is this really helpful? Well, if you did a good job in your reconnaissance phase and you know some information about the person, most people tend to pick passwords that are familiar to them. Dog's name, spouse's name, city they grew up in, high schools, their favorite football team. You start putting those things into your dictionary program. With a hybrid attack, it can start having some good results and be able to find these complex passwords that are based off something the person knows. So, what are some of these password cracking tools that are out there? Well, one of the most popular ones out there is called Cain Enable. And what Cain Enable is, it's a multi-purpose tool that performs password cracking, Windows enumeration, and VoIP sniffing. But we're really talking about the password cracking portion here. It can do dictionary attacks, it can do brute force attacks, and it can do those rainbow table attacks. And the nice thing with a rainbow table is that, again, it's going to speed up those dictionaries and become the fastest method out there. Now, what is this picture up here above my head? Well, you'll see on the left side it has length 6, 7, 8, or 9. That's the length of the password. So if I wanted to have every single possible password out there that is up to 6 characters long, that's about 2 gigabytes of text. If I wanted all the way up through 9 characters, that's 60 terabytes of text. And so again, most people, their passwords are up in the 12, 14, 16 characters. You could see how large these text files are and how long it's going to take, even with using a rainbow table, which has pre-encrypted, pre-hashed information. It's still going to be tons and tons of information and will take a long, long time. That's why we say passwords and having strong passwords is by far the most important thing in security. Another one we have out there is John the Ripper. Now, John the Ripper can crack Kerberos, landman hashes, and more. And the passwords that are cracked, though, they're not case sensitive. So if I come back and it cracks it and says it's password, it could be all capital, all lowercase, or a mixture of the two. I don't really know, but at least I've gotten it down into something reasonable. And now the fact that I know that it's 8 characters and it has password as the letters, I can start going through it, and there's only a couple of options and I'll be able to figure it out pretty quickly. Orfcrack is another one that we have out there for password cracking, and this one is really efficient because it uses rainbow tables, so it's very fast. But again, those rainbow tables can be very large. Like I said, if I had up to 9 characters, that means all the passwords between 0 and 9 characters long, every possible combination, there's 60 terabytes of text out there to symbolize that. And so what's one of the ways that we can do this faster? And the one that I'm going to use is CrackStation. So if you go to crackstation.net, it uses rainbow tables for fast password cracking, but the nice thing is it's all done on their servers. So for instance, if I take this landman hash on the screen and I copy it and I paste it into crackstation.net, what will I get? Passphrase floppy. It comes back fairly quickly and you'll be able to find that. Now, if instead I use that doing Orfcrack, it could have taken minutes to hours depending on where it was inside the rainbow table. But by using it at CrackStation and using that cloud computing architecture they have, it can come back much, much quicker for me.